Hi everyone, and welcome to Jank Busters. I'm Tom Wiltzius. I'm a product manager on the Chrome graphics team.
Yeah, I'm Nat. I hack on the rendering system, write code, stuff like that.
And we're here today to talk about Jank on the web, what it is and how to fight it.
Yeah, so what we usually do when we talk about Jank is we sort of start with like what smoothness is, right? So you've got a screen in front of you, or a lot of you do. And the way that thing's working, right, is it's tricking your eye into perceiving motion, when in fact what it's doing is it's updating the screen, those LCDs, really, really, really fast, once every 60th of a second. Now sometimes it's like 50 hertz, sometimes it's 54, it's all over the map. But the idea is you've got to do it fast enough so that your eye perceives this as movement, and if you do so, then it's smooth. If you don't,
then you get Jank.
Yeah.
And Jank comes in a whole variety of formats. We refer to something as a hitch when you drop a whole bunch of frames in a row. So say everything stops for 200 milliseconds. Or a low frame rate is when maybe things are still happening routinely, but they're not happening as often as they should be. So you only get a new frame up every 50 milliseconds instead of every 16 milliseconds, that kind of thing. And the worst is when these things combine and you get a really variable frame rate. You get new frames coming up on the screen at irregular intervals. Your eye is really well attuned to that sort of irregularity because it's how we notice motion. And if you look at something that's supposed to stick to your finger, right? Like something like, say, this div that's scrolling up and down. It's pretty fast because this resolution's a little smaller than the monitor is.
Yeah, like try this on a high-res device or a low-end computer, for example.
Then you'll see that once that physical metaphor gets broken of your finger moving and the screen updating sort of correspondingly, then all of a sudden things start to feel really bad, right? And this is the difference between something that feels smooth and feels really nice and responsive and something that feels janky. And this is what we're talking about when we talk about Jank.
Yeah, I mean, basically, we all talk about, it's all well established, right? You've got to optimize your loads, minify, do this, do that, make sure that you're doing the right requests to your network. But there's this second-class citizen, right, which is the rendering system, which we haven't typically had to think about because, frankly, the old web pages of yesterday, you move up and down, right? And the browser can do lots of tricks to make that just fast. But nowadays, when you have complex, beautiful-looking websites, for those to feel native, for those to stick to your finger, the thing you have to do is you have to run calculation of layout. You have to run JavaScript. You might garbage collect somewhere in there. You might have some animation that you have to do. You might accidentally query a style select. Do you want to interrupt me and make me say something similar?
So it's really hard, right? Like there's a lot that needs to go into that 16 milliseconds, and Nat is rattling off this list of things, but what we're here today to talk about is the stuff that I guess I would summarize as the green bars in Chrome's DevTools, right? So yes, there are a whole wide variety of things that you can think about when you're thinking about performance, and that includes all the network latency stuff that Nat's talking about. It includes a lot of JavaScript events. But what we're here today to discuss is what we call rendering, and that sort of breaks down into painting and compositing, and we're going to talk about both.
And in fact, there was a really cool post by Paul Lewis just today where he said, I bet you that if you go to your favorite website out there, you will see a whole lot of green and purple in the modern web. And I would encourage you to give that a try, and I think you'll find there's a lot of websites out there that are basically paint and this green bound, and that's what we're here to talk to you about. That's jank busting.
Yeah. So how do you jank bust? First step is you try to paint fast, right? Try to get those green bars to be as short as possible. We're going to talk a little bit about how to do that. But better yet, you're going to try not to paint at all. And we're going to talk about that in probably greater detail. And lastly, we're going to go into a few cases where, because the platform is not always as obvious as it might be, you end up painting when you really don't have to. And you might not even be noticing this kind of thing because it's the sort of thing that you need to use tools to sort of proactively look for. But we'll show you how to do that, and we'll show you how to hopefully get a better glimpse into what's going on under the hood.
So you've heard us use the word paint, right? And I think that's really the building block here that we need to talk a bit more about. So you go to Goog, and you get this, right, which is a blinking cursor, right? Ooh, earth-shattering. Now, what's going on behind the scenes here is that Chrome has, the cursor's a lie. This is not the operating system doing it. Chrome has just a bitmap in memory, just of RGB colors. And the cursor is just some dark colors in that bitmap. And Blink/WebKit has bookkeeping in it, very exhaustive bookkeeping that says, ooh, this part of the shadow DOM changed. I'm going to repaint this part of the bitmap because it's different now and I need to put a cursor where there wasn't, or I need to remove a cursor. That is called a repaint. And so there's a repaint rectangle, you can imagine, right? When something changes visually, we have to repaint it. And you can sort of imagine that the cost of a repaint is, to first order, proportional to how much you have to repaint. So certainly, blinking that cursor is going to be a whole heck of a lot cheaper than blinking, say, all of Google to black and white, right, back and forth. It's just sort of intuitive, right? You have to touch more bits of memory. But, of course, that's not the whole story, or we could all go home, right? The other part of this is that not all paints are going to be the same speed. So, of course, if we want to just fill in a part of the page with white, it's going to be a lot cheaper. But if we go to this I'm feeling lucky button and you actually really look at it, and actually I think this audience more than anybody understands sort of the details in some of these elements. All of those little effects you see, the anti-aliasing on the text, the rounded corner, the line being anti-aliased, all of those things are costly, and they're costly in the sense that they eat CPU in order to perform. The computer, the CPU just has to sit there going, oh, is this line on the pixel or halfway on the pixel? And it just, noms away at the CPU. So the I'm feeling lucky button is 3 or 4 times slower to paint than just a white area. And this sort of makes sense. And then if you go to a low-end device like a phone, it's even more, that difference is even more amplified. So this is all sort of my long-winded way of saying don't paint, right? Like, don't do it. And in particular, if you're thinking about mobile, really don't do it. And to help you with this, we built into the browser, and not just we, Chrome, pretty much all browsers now have this concept of a layer, right? The best way to think about layers is we look at your DOM, and we go, oh, this thing is an overscroll div, like an overflow scroll div. You're probably going to move that up and down, right? So, hey, let's instead of repainting in order to make that scroll happen, let's take that thing and make it into sort of like a Photoshop layer, right? And then we can move the layer up and down, right, and fake it out. And then what we'll do is we'll store the contents of that layer on the GPU. And then when we actually just do an action on the page that moves the document up and down like this, all that you have to do is ask the GPU to composite. So now in modern Chrome, you'll see 2 steps in the timeline. You see paints, which you don't want to do, and you see composites. The composites are us taking these layers and smashing them down. And if you do that, Chrome can really hit some super high smooth frame rates, 60 hertz, whatever it is. If you don't do it, and you paint, then you're in trouble.
Right. So I'm going to walk you through sort of an example of that scrolling working well or not. This is a site. It's pretty simple. It's a list of 100 images. And you can see that, again, demos might be slightly off modulo the resolution being slightly smaller than what's normally on this laptop. But this scrolls pretty smoothly. I can fling up and down in this area, no problem. You can see that the scroll thumb on the right side is updating really nicely. And I would not call this janky, right? But you'll notice that as I'm doing this, I've got the mouse cursor sitting in the gutter of the page. And if I mouse over one of these images, I've got a simple animation effect that happens just based on the hover pseudo class, right? And I get a little bit of a drop shadow. I brighten the image a little bit. Nothing all that fancy, but it is an effect that changes things a little bit.
It's 2 or 3 lines of what you'll see is very destructive CSS.
Exactly, and you'll see that if I try to do that same scroll, it's pretty fast here. If I try to do that same scroll with the mouse over the images, then all of a sudden things start to kind of fall apart. And the difference is something that I'm going to show you right now. If you open up DevTools and you turn on Show Paint Rectangles, which is our beloved feature in DevTools, you can see what the difference is. The difference is whether or not you're painting during the scroll. So if I just move up and down now, what's happening is that Chrome's pre-painted a little bit behind the scenes, and it can pre-paint about fast enough that you don't actually get paint operations that happen when you actually need to show new content on screen. And so that means I can sit here scrolling up and down, and I don't get any red rectangles, which are the areas that are being repainted just like the blinking cursor from before.
So this is that layer analogy, right? That in this case, the layer analogy is working well, right? You're not seeing any repaints. It means that you're going nice and fast. You'll hit 60 hertz.
In fact, the only thing repainting you'll notice is the scroll bar on the right-hand side there.
And there's no helping that.
If I mouse over one of these images, you can see that throughout the course of that hover effect, I animate in and out the classes I'm changing, and I'm getting repaints sort of every frame of those effects animating, and that's really, really painful, right? Not only is it making the animation run a little bit slow, in theory, if I do this and scroll up and down, all of a sudden I'm having all these red rectangles flash during the scroll operation.
Yeah, we saw this happen on a popular photo blogging site thing where you can sort of guess what it was, where basically they have this nice hover effect, and if you had your cursor in the wrong place, the site was just completely unusable.
Yeah, and so, I mean, hover is something we're picking on here, but hover is actually relatively simple to deal with. If scrolling performance is important to you, you can turn off the hover effect during scroll, right? Like I can achieve that with an on-scroll handler and a timer, and indeed if I do so, you'll notice that I don't get the repaints during the scroll, but then as soon as the scroll stops, I sort of get them again 200 milliseconds after the last scroll event. And that's great, right? But it does change the UX of the site a little bit. And this is the kind of thing that you need to start sort of reorienting yourself to think about when you think about design, right? Because you can do some really nice visual effects on the web today, but it's also really easy to shoot yourself in the foot performance-wise. And I'm going to just sort of assert that things like good scrolling performance are actually just as critical to the design and feel of your site as really nice visuals are.
I'm going to assert that as well, just to be with him.
Right. So again, I'm picking on hover. Like the point here is not use hover. The point here is use DevTools to see what's going on. Right. So there are a wide variety of ways to get paints that you don't necessarily need or want during a scroll. They include some of the things on this list. And if you do get paints during a scroll, it's not necessarily a problem, right? Like it's entirely conceivable that the paints could be so fast that you can afford the paint and the texture upload to the GPU and the composite and whatever else goes into the rendering pipeline.
But just don't paint. Like don't get into a dangerous situation. Just don't paint.
Because there are a lot of things that can make the paints take a long time, right? And like, yeah, the rounded corners and drop shadows and the other effects that we're all sort of familiar with can play into this. But there can be a lot of other things that are a lot more subtle. The bane of our existence right now in this category is definitely image decodes, because it's really possible, especially on high resolution screens, to blow a lot of the internal image decode caches inside of Blink/WebKit, and then like everything.
So this slide, don't sit there scrolling down, scribbling down this slide or like whatever. We're constantly changing our minds in Chrome and screwing up. And Chrome has a very tiny brain, and it gets really confused really easily. So this is the current list of
bad
things. But the best thing to do is pay attention to the techniques we're showing you to measure the source of jank, and then sort of deal with the latest canary of whatever the thing is at the time.
Exactly. So. And the layer model that we're talking about that's so great for scrolling, all of this applies to other types of animation too. There's nothing sort of special about scrolling other than that we've put sort of an extraordinary amount of work into trying to make that particular operation
you kind of
fast.
scroll a lot on the web. That's
yeah,
like
because it's so common. But like a lot of the same primitives are what we use to try to make things like, say, CSS animation also work well. So if I open up this demo, this is super ugly. We're not designers. But
we're trying.
You'll see that this is just a drawer, right? This animates in and out. It's using CSS animation. So great, right? Like I'm using modern techniques. I'm telling the browser what I'm trying to be doing. It should just make things good for me, right? Well, kind of, but the way CSS animation works, you can animate all sorts of stuff, right? And there are things that you can animate that don't play very well at all with this notion of everything needing to fit into 16 millisecond frames. For instance, what if you need to do a lot of reflow during the animation, right? That means that every time a new position ticks out of this animation running, stuff could be like moving around, and that's the kind of thing that Blink/WebKit gets really, really bad at really fast. So if I
that was cool.
Surprise. If I open up DevTools again and I have Show Paint Recs on, then you can see that during this animation, I'm actually painting every single frame of it. Again, that red flash, that means repaint, and that's bad. That's really bad for animation. And you can even see that it's a little jerky, right? All I'm animating here is the left property. And if I had, say, text in the middle, you would see it reflowing and stuff. And that reflow is really, really negative for performance. If I open up the DevTools timeline and I take a recording of that animation running, you can guess what you're going to see. But if I zoom in here, I get like style recalculation, relayout, paint operations, composite layer operations.
And on that paint thing will basically, if you take this to a low-end machine, that paint can balloon to 30, 40, 50, 60 milliseconds, you know, in a blink of an eye. You put an image on there, you put some shadow on there, you put a border, you sneeze, bang, there goes your 16 milliseconds.
And you might be saying, like, well, wouldn't it be great if the browser could kind of make this better for me? But again, there's something kind of fundamental to the way the left property works that makes that hard, because elements flow, right? So instead, if I use something like a WebKit transform, this is probably a trick screw up my demo. This is probably a trick you've read about online, right? Like, these transforms promote things to their own layer. So the layers we're talking about for scrolling earlier, they apply here too. And if I run this animation using a translate X for my transform instead of the left property, then all of a sudden those red rectangles go away during the animation. And that's great, right? Because that means I'm not painting anymore. And indeed, I can confirm this if I go back to timeline, take a recording, run the animation, stop it, look at what's going on here. All I'm seeing are composite layer operations. And the reason that we can get away with this is because the transform takes the element out of flow, right? And it lets us sort of make some guarantees about the thing inside the transform being kind of independent from the sort of parent container. And that's really nice. But you'll notice I'm not quite done yet, right? Because I'm still seeing these red flashes at the beginning and end of the animation. And this is the kind of thing that if you're thinking with 16 millisecond frames in sort of the forefront of your mind, should stand out as potentially problematic, right? Because that means that as soon as I click the button, a repaint's going to happen. And if that repaint might be slow, then all of a sudden there's this lag when I click the button, right? And that sucks. That's really bad. That's not what you want at all. You want things to feel really responsive. You want them to respond immediately as soon as you click something.
The other kind of responsive,
right? Right. And so it so happens that there's a relatively easy way around this, in that if you use a translate 3D instead of a translate X, the thing gets promoted to a layer all the time. If I want to illustrate this, I can use a great feature of DevTools called Show Composited Layer Borders. And if I turn that on, you see this sort of cyan grid. The grid's not important. What is important is the sort of yellowish-orange border that goes around the viewport in this case. And that yellow-orange border means everything inside of this is in its own layer. So these layers that we keep talking about, here's a way to sort of visualize them. And if you look at what happens as I run that animation, you can kind of see, again, if I zoom in, that the drawer gets a yellow-orange border of its own throughout the course of the animation. But if I make the red rect go away, the repaint rect go away, you'll notice that there isn't any yellow-orange border before or after the animation. And that's bad, right? And that's the reason that you get those red flashes, the repaints, right at the beginning and right at the end. Because what happens is that I start the animation, the drawer gets ripped out, put in its own layer. This is a new layer, so now Chrome needs to paint the thing that didn't exist before, right? That takes arbitrarily long. And then we recomposite, the animation runs, and then we smush the drawer back into the base layer of the page. And when we smush it back into the base layer of the page, we have to repaint that area, and that's why you get the second red flash at the end. If I use the translate 3D instead of the translate X, this is sort of incidental, but you don't get those.
Well, it has to. You get, yeah. Yeah. It has a tiny brain, so it gets confused.
Right.
It's a well-meaning brain.
You'll see that now there's this sort of orangish border even when the animation isn't running. This is what we call sometimes pre-promotion, because the layer is, we promote the drawer to its own layer at all times.
So if you have something that you think will move in the future, you need to start thinking about not giving it a layer at the last second, like in the on-click, but having it have a layer well in advance so that it's already primed up and ready to go, so that when you get that on-click, it just starts moving. And no paint means fast.
Right, and you might be thinking this feels really hacky, and you would be correct.
Yeah, this is the platform right now, and it stinks. I'm sorry.
But it is something we're also actively changing, because, for instance, the translate X example I have in the latest canaries, it actually stopped working as a bad example because when there's a WebKit transition or a transition property on the drawer element, we actually are now teaching Blink to be smart enough to actually pre-promote the thing on its own.
But you need to think about this because it's just, you don't assume that the platform will get it right yet. Someday, maybe, but not yet.
Exactly. So that is layers for animation. But sometimes you need to see more than that, and that's going to show you
Yeah,
how to dig out.
We like giving you eye strain with the yellow lines, those thin little yellow lines that are absolutely critical for performance. Like, that's really nice, right? So what we've done is we built an internal tool. This is quite a bit more technical than, say, dev tools, but what it will do is it'll let you see your layering. So here I just have a cats search, and when you use Chrome's frame viewer, and you can Google it to find info on this, what you get is you get a list of frames that were drawn by the compositor. So for example here, and then what you can end up with is this, which if you remember my Gmail slide that showed the Gmail layers, well, this is this, but for your site. So these are your layers in your site. And just to give you sort of a more complex example, we've got plus, and here's plus here. And the interesting thing here is as you scroll, if the viewport sticks, there it is, over there, you can see sort of there's a viewport here, up there, right? And then we've got the content for everything below the page. And so in this case, as you go between your pages, what you'll see is the actual viewport moving. You'll see the layers, stuff like that. And this can end up being very useful because you can pull things out like why a layer was created and how much GPU memory it's using. It's sort of advanced stuff, but if you really are going to try to push your content to the limits of the current platform, you may want to check this sort of thing out.
Particularly on mobile, where you run into things like memory constraints a lot more readily.
Yeah.
This is kind of what we're pushing.
We're going to be pretty brief on that, though. It's a pretty low-level tool, but grab us if you're.
Yeah, we're happy to talk about it more later on. Last category of stuff we want to talk about, which is that there are times when you can get one of these repaint flashes, even if it seems like you didn't deserve it, and this can happen in all sorts of scenarios, but I'll walk you through one. If I click this button, I add a div to a container. Pretty simple.
Fantastic.
It's 100 pixels square, nothing complicated at all about this styling, right? And if I open up DevTools and I have the Repaint Rex on, I'm going to turn off the layer borders. Have the Repaint Rex on. As I click to add more, you can see that I'm sort of repainting where the button is, and I'm repainting where the new divs are. And as I get sort of off screen adding more, I can sit here all day mashing this button, and the only thing that repaints is, well, the scroll bar and the button, right? This is great. This kind of makes sense. It's intuitive to think that, well, if I'm changing something in the DOM, but it's only affecting things that are off screen, shouldn't need to repaint, right? And that's great when it works. But unfortunately, repaints don't only happen when you make changes that end up with visual impact. It's entirely possible to do something like, say, toggle the padding on this container block that you can see outlined in black. And when you do that, you end up repainting the entire container. And again, if you think about it a little longer, maybe this makes sense again. Because from Blink's perspective, what happened? You added a little bit of padding, but potentially everything inside reflowed, right? This is like the beauty of the web. And when that happens, all bets are off about the content inside of the container. Blink needs to be very, very conservative about maintaining like what might be dirty, what might be out of date, and we have to repaint. And when we repaint, this is what you get.
So it's really important to think about this in terms of like, Blink can get confused, and it gets confused very easily. So you have to monitor for this sort of thing during your development. There are ways with Chrome Developer Tools Protocol to get the paint stream out so that you can monitor in test harnesses, for example. But you need to keep an eye on this sort of thing because stupid, innocuous stuff like setting width to the same thing that it used to be can sometimes cause this, and then it'll ruin your day.
And this is the kind of thing that, again, we're trying to make better all the time, but there are always going to be pitfalls like this. So it's the kind of thing you need to sort of watch out for.
Yeah, but I mean, ultimately, there are just times when you do your best, you've got everything done as well as you can, but you do have to paint. Sometimes that's you've added something to the DOM and you actually really do need to paint it. And sometimes it's just an effect that you're just not willing to compromise on. You know, it might be the gee whiz thing that you've done. You know, who knows what it is, but it happens. So we started off with sort of this thing up, right? And it's a little jankier when you go full screen and blah, blah, blah. So we're showing you this as sort of an example of bad content, right? Chrome has a feature called continuous repainting mode, or DevTools does. So if I check this button here and go back, now what Chrome is doing is it's constantly repainting. So it's a little hard to see, but basically the whole page has gone a little red, and that's because it's got a big repaint rectangle on all of it. And what's happening here is Chrome's constantly repainting all the time as fast as it can go. And up here is the number in the top right, the paint speed that we're sustaining. So this is assuming that you've just, you've confused Blink and it's going horribly. So when I unplug projector here, this goes at like 167 milliseconds. The idea here, though, is you can sit there now in DevTools. We're going to have to play some window size acrobatics here to get that up on the screen. Okay. So we have another piece of feature addition to DevTools, which is the H key on the element panel. Super, top secret. Yeah, we're living large. So we've got this H key, and what it does is it hides that element and everybody that descends from it. And if you watch that number that's being reported, we're going from a big number to a really, really trivial number. Not to 0, and that sort of makes sense. We've still got to set the page to this lovely puce color, right? But it's cheaper. So we can go, oh, clearly this tells us that the thing that's slow painting is inside my body. Well, duh. So this is simple. It's just a bunch of image tags. So I can do the same trick with styles. So I can hide the box shadow. And now we're really cranking. We're going at what, like 8 milliseconds, right? So now we sort of have this idea that, well, maybe 22 of those milliseconds, or watch me do math, some amount of that is going to the drop shadow, right? We can bring it back on and turn off the border radius, and you can see that, well, maybe it's that one, right? Now, these don't always compose. Sometimes you confuse Chrome. So like if I remove both of them, we're not really going incrementally much faster. So what's happening here is you're hitting a particular corner case in Chrome's rendering system where the composition of these two different styles is particularly slow. Don't go home and say, hey, this is one to avoid, because we may fix this tomorrow, right? We probably won't, but we might. And again, keep the technique in mind. We've found a lot of sites where there's one effect that's particularly slow. Now, not to rag on Gmail, but in Gmail, there's a little drop shadow between the top bar and the message list. And there's a little drop shadow that's like a half pixel. And that costs 1/3 of the rendering time of the entire page. This is important to factor into your design discussions, right? This is a back and forth that you need to be having early on so that you don't get a week away from ship and go, oh my God, we can't afford this. Oh my God, we're up a creek. So continuous painting mode, definitely check it out. We also have more fanciness coming in that high-tech tool. Some of you may have seen in the blog sphere about Skia debugger and some magic you can play. That will start showing up in the frame viewer, so more coming.
That's right. So to wrap up, again, our main takeaway here is tools. You want to ask yourself a couple key questions when you're debugging site performance. You want to ask yourself why you're painting. Well, first, you want to notice that you're painting using show paint recs. And then you want to ask yourself why. You want to see if you can avoid it, either through judicious use of layers or by just trying to not touch the DOM unnecessarily. And if you really can't avoid it, then you want to make it as fast as possible using tools like continuous painting mode that not just
and it's especially important because Chrome's changing a lot. So be familiar with what currently is bad because it'll change again. And also keep in mind that your computer that you're probably developing on is a really good one. I see a lot of sort of good machines out there, right? That is not what Ma and Pa have, and that is most of the web. Yeah. So keep that in mind. When you get something going at 7 or 8 milliseconds on your computer, know that that's 2 or 3 or 8 times slower out on the real world.
Or like on tablets or like whatever.
And a really good number to walk away from is, or walk away with is Wikipedia. If you just do like the cats page on Wikipedia, I think it takes about 150 milliseconds to paint on a Nexus 7. So that is not jank free, right? So keep this stuff in mind.
Exactly. With that, I'm not sure we have time for questions, but this talk and other sort of resources, just a bunch of links to similar content, is all up on jankfree.org, which is the site we maintain. A lot of that content actually lives on HTML5 Rocks, which is the Chrome sort of developer relations website. Our contact info is up here. If you have thoughts on any of this, we're always happy to talk about it, and we like talking to developers.
Shoulder to cry on.
Yeah, we'll be around tonight too if anyone has a site that's slow or whatever. we can take a look.
Thank you all.
And thank you very much.